Good morning to everybody. Welcome to everybody to our traditional CMCC webinar. My name is Simona Masina. I'm a scientist at CMCC, and my role today is to be the moderator of this seminar. Thanks to everybody. I have been told that 190 persons registered to follow the seminar. So hopefully we will have most of them already available and connected to the GoToWebinar. So these seminars are hosted and organized by CMCC for the people, for those who don't know yet what is CMCC. I will give you a short introduction. The Euro-Mediterranean Center on Climate Change is a non-profit research institution that was established in 2005. And it was founded with the main goal to establish in Italy a center of excellence focused on the study of climate change and the impact of climate change. CMCC mission, yes, exactly, thanks. CMCC mission is clearly to study, to investigate and model our whole climate system and the interaction of the climate system with the society and the environment. Since December 2015, the center has become a foundation. And this foundation, this research institute is spread in different places in Italy. If you can go to the next slide, we will see the different divisions of CMCC. These different divisions are located on different places in Italy. For example, Giovanni, who is Giovanni Coppini, that will I introduce you shortly, is located in Lecce. In Lecce, we have two divisions, a division of advanced scientific computing and the ocean prediction and application division. In Bologna, where I am, there are two other divisions, the climate simulation and predictions divisions and the ocean modeling and data simulation division. Then there is another division in Capua, dealing with regional models and hydrogeological impacts, two divisions in Venice on the risk assessment and adaptation strategies and on the economic analysis of climate impacts and policies. And I'm sure I forgot something. Yes, last but not least, the division that is divided over Viterbo and Sassari on impacts on agriculture and forest and ecosystem services. So a network of university and research institutions all over Italy. Okay, but now let's come to the speaker of today. Today we have Giovanni Coppini. Giovanni Coppini is a senior scientist at CMCC and is the director of the Ocean Prediction and Application Division. Giovanni holds a PhD in environmental sciences from the University of Bologna. Since 2003, he has been deeply involved and he has been working in the field of operational oceanography. I will read all his international roles. He is a co-chair of Mongoose. Mongoose is the Mediterranean Oceanography Network for the Global Ocean Observing System, and he is the Emergency Response Officer for the Mongoose REMPEC agreement. He is also a member of the JCOM expert team on maritime safety since 2012. And a very important role is since May 2015 is actually the leader of the Copernicus or CMEMS Mediterranean forecasting centers. Is the CMEMS center that provides at European and international level the ocean forecasting for the Mediterranean Sea, and is also the deputy leader for the Black Sea SeaMEMS forecasting center. I hope I said all the most relevant roles. Now, to finish this introduction, I would like to remind all the participants that they have the possibility to ask questions during the presentation of Giovanni, but actually they cannot directly ask. They are yeah, they can use this device. You will find on your control panel of GoToWebinar, that should be clear on all your screens, place with questions. Okay, so the possibility that you have is to write the questions during the presentation, or even after that, during it would be better. So at the end of Giovanni's presentation, I can read the questions to Giovanni. So please write your questions, and also it would be helpful for us to track who you are. Also write your name and your affiliation. The last ad before I give the floor to Giovanni, I remind you also, everybody, that the seminar will be available on YouTube and on the CMCC website. Okay, I think that for now my role is done, and I give you the floor to Giovanni.
Thank you, Simona, for a very nice introduction. I will try to introduce the blue growth concept and give an example of how to develop products for the benefit, let's say, of society and environment, with a focus on the Mediterranean and Black Sea that, as Simona was mentioning, are familiar to me and to my work environment, but of course are only an example for blue growth. I wanted to start this session, this discussion with you, try to give you a very brief overview of the international framework, and I ask myself which is the framework in which we are developing a blue growth application. I feel, of course, there is first of all the European context that the European Commission has defined in terms of policy and funding system that reflect in all the Horizon projects, but also in several DG Mare calls. So it's important to develop the application. More international, I'd say, and very familiar to operational oceanography, there is the GOOS framework, and in particular in Europe, the EuroGOOS and MonGOOS systems that are not only dealing with observation, but also focus on operational modeling and application at the regional level. JCOM is the other WMOAOC commission that deals with the definition of the international practice and standards for observation, forecasting, and climate change application. So, for instance, some of the applications that are developed and offered in the blue growth context are also discussed at the international level within JCOM, such as the one for maritime safety. The GODI framework is the one in which the international community, so not only the European one, discussed the modeling, data simulation, and also the usage of the observation. And of course, as you can imagine, is very important. The new, I'd say, developed in the last few years, GeoBlue Planet initiative is also very relevant because it focuses specifically on marine application. And in July, for instance, there will be a session, a workshop in Toulouse about marine application, of course, very relevant for blue growth. I wanted to mention marine, that is a very small, let's say, compared to the others, regional in our Apulia region collaboration agreement, but very focused on blue growth, so I will use it. You don't see SeaMEMS mentioned here because I will dedicate more to Copernicus service later, but of course is a European initiative relevant in this context. The blue growth has been somehow defined by the European Commission to focus on some of the industrial and environmental characteristics and issues and activity of Europe. And some very important sectors of blue growth are, for instance, coastal tourism and maritime tourism, and also aquaculture. So these would be some of the examples, but more in general, of course, it refers also to the safety of the activities that the human are doing in the environment, in the marine environment, and to the safety of the environment itself, so that these, let's say, services and ecosystem services are preserved for the present and future exploitation. As far as it concerns the more activities at international level related to operational oceanography, for instance, Eurogoose and Mongoose focus within the different Goose Regional Alliance to foster operational oceanography activities. Here you find the website of Mongoose that describe how we we do develop the products starting from the observations and adding value through the modeling process, and then developing the downstream. When we go to the very local framework that is marine, what we have done in the last 2 years in the Regione Apulia, we have developed a network of both industry and research and institutions to collaborate for the development of blue field applications. So in synthesis, it is a network of more than 50 actors, private and research and public institutions, that have built a meeting place that through workshop and seminars and projects together develop and exchange, develop activities and products and exchange information. Of course, we are only at the initial level of development. Here you see how differ is the variety of participant to marines with a large number also of private companies that you understand are very important in the development of blue growth application. Marine has identified some as decline, let's say, as specify some important sectors within the blue growth, at least relevant for the Apulia region, and priorities, which I think are relevant also at the European and international level, that range from the classical aquaculture and fishery with sports and tourism activity and so on. You can see listed here, but include also, for instance, the agenda Digitale Marina, so sorry for the Italian, the digital agenda for the marine service that you will see some example today. What we have done in the last years is that we have put people together, more than 200 experts, to discuss strategy and identify priority for the Apulia region, mainly on the fishery aquaculture, on territory environment and tourism, but also on robotics and mechanics, biotechnology, and digital agenda and modeling. So here are the results of the first process of marine. Now, I will start now to provide you some more detailed information on specific product. First of all, I'd say that Blue Growth is born focusing on the users, so on user demands. And the field of application of the services we are developing in these fields are quite large, but and they range from safety to navigation, offshore activity, border surveillance, fishing and aquaculture, tourism. So today I will show some of these examples. How do we develop these services? So I will spend some time to present this slide because it somehow synthesizes the entire presentation and the concept I wanted to transfer to you. So first of all, there is a capacity of observing the ocean. The ocean in terms is observed both in terms of remote sensing and in situ. And these data are essential for the, let's say, the past and near real-time characterization of the ocean. Then we do model the ocean, assimilating the data that has been observed. Just to mention some of the, let's say, provider or context in which these data are collected are, for instance, GOOS, the SeaMEMS itself, EMODNet, and also ECNWF for the atmospheric forcing. Once data are collected, basically CMEMS started to run the global ocean forecasting system and then the regional model that I will present in a while. And then through the downscaling capacity, we go to model and of course also observe, but mainly I will discuss the modeling capability to model the coastal areas up to the harbor level, and we have example in several areas of Italy, but also Spain and others European nations that has this capacity of operational modeling at the harbor level. The modeling, let's say, is the intermediate products that allow the downstream services development in terms of decision support system. Here you see, in brief, some of the example of decision support systems such as ship routing, visualization service, search and rescue that I will mention later. Of course, this is, I would say, important to underline that in this framework, the collaboration with industry start to be very relevant because because we also enter into the market exploitation domain, because most of these services are not paid directly by Europe, part of the development maybe through research projects, but are done for the market, let's say. While the Copernicus component is funded and developed through European funding. The Copernicus Marine Service is collecting the data and producing reanalysis forecasting at the global ocean level and for the regional seas. Here you see an highlight, let's say, of the different European seas. On the website of Copernicus that I will mention later, you will find all the available data. An example, I'm not sure you will be able to see the movie, but this is an example of the global ocean forecasting system visualization in which currents are provided freely available to the users, and for instance, in fact, Copernicus provides this data. Of course, this data comes to be very important when we do the regional modeling, because the global ocean forecasting is essential to provide the boundary condition. An example is the Mediterranean Sea, in which the boundary condition is provided by the global ocean forecasting system, and then downscale to 124 resolution in the Mediterranean area. Another example that we contribute to is the Black Sea ocean forecasting system that provide every day the 10 days forecast for currents, but in general, both for the Black Sea and the Med Sea, the products include also the biogeochemistry, so forecasting of the chlorophyll and nutrients at the basin scale, and waves. Of course, the physical temperature and currents and the biogeochemistry is 3D, three-dimensional, so it goes down to the bottom of the ocean. One important aspect of CMEMS is that it is operational, is free and open access policy, is applying a free and open access data policy, so all the data are available also for commercial exploitation. I'd say especially to be used for commercial exploitation, and it is assisted, so it's a free and data policy that is assisted through service desk, and so you will find people ready to provide you answer to your questions, both in terms of quality of the products and service, and also I wanted to show you this complex slide, but that express somehow the regular capacity of SeaMEMS of validating, so the effort of validating the forecasting products. In this case is an example of the validation of the physics, biogeochemistry, and waves for the Mediterranean Sea. That is done at a different time scale, so from the daily to the yearly assessment, and all these products are available on all these products and documentation. For instance, what we call quarterly validation report is available on the marine website together with the data. So each type of data has its own validation for the user benefit. Now, going to, I will start now the part of my presentation related to the application, to the blue growth application. The first application I wanted to introduce is a web mobile application that has been used by more than 100,000 users. It is a commercial one, but it has a free version, and its scope is to provide ocean weather forecasting for the Mediterranean Sea, and is available for the Apple Store, for the Apple and Android versions. It provides ocean forecasting from Copernicus, both for currents and waves, satellite observation from Copernicus, and the weather forecast from ECNWF. That is then that is acquired and let's say put back on the application. It is innovative because it's capable of providing the products also with the zoom capability. So trying to offer to the user experience that allow the users, it can be a sailor or a surfer, to navigate and understand the data and the forecasting, in this case, with a good quality and good experience. It includes, as I mentioned, waves and currents at different level of zoom, and also the meteorological. Here is an example of cloud coverage over the Mediterranean and the southern European area. Another exploitation that we have done for sea condition, I'd say relocatable sea condition, has been developed in use case scenarios for the America's Cup sailing race in the New York Harbor, in collaboration with Alan Bloomberg and the Stevens Institute of Technology. A couple of years ago, we developed a mobile, a web responsive, capable to be looked also from the mobile, with a very high resolution forecasting that is developed, let's say, by Stevens, but visualized by our sea conditions. So this was a very exciting experience we did in the past. Another application that I wanted to introduce you is VSEER. It's let's say adding value to the visualization, to the ocean and wind and atmospheric forecasting, and in addition to the visualization, the visualization of the forecasting allow you to plan your route either a sailing boat or the motorboat. In this case, for instance, the example of a motorboat that sailed from Italy to Greece, the red route is what we call it geodetic, so it's no weather condition route. So is the shortest without taking, and is calculated without taking into account the wave forecasting. The black route, instead, that you see is changing direction in time, advising the sailor to go, for instance, along the Greek coast, first along the Italian coast, and then cross the Otranto Straits, and then along the Greek coast. This decision is suggested to the user by the software that take into account, so we see take into account the wave forecast that evolve in time and space. So you see a snapshot, for instance, of wave of above 3 meters in this area. So to avoid high sea, the software is optimizing the route, advising the black route. Similar application has been developed also for sailing boat, in which the sailboat starting from this point and progressively reaching the destination here in the south. It's sailing, is planning the sailing route, taking into consideration the wind forecast that is evolving in the 20 hours of sail. So you see that there's a very articulated and complex route that change because of the change of the wind forecast. This is another application of this service. This is commercialized on the web and on mobile application. In the web version, there is also the VSIR for sailing boat. In few minutes, less than 1 minute of computing time, the sailor is able to plan his route, in this case from Bari to Dubrovnik. You see again, the black line is the geodetic no weather condition, while the red one is the more complex route that arrive earlier. You see here in the graph, the time duration of the red route is shorter, and it takes into account, in this case, the wind forecast. Then the user interface allow you to click on the route waypoints and get information and display in the background the wind forecast and get some information on the navigation you should follow. Together with this application, software application, we have also developed the SeaWithYou tablet and server, that is a system that can be installed on board and allow the automatic download of the Meteocean forecasting system products of sea condition, and then is interfaced, automatically interfaced with both instruments, and the information collected from the both instruments can be displayed on the web of the SeaWithYou tablet. Other application that we have recently developed is very high resolution forecasting for fish farm. This is a regional project of region Puglia, and in which we provide high resolution forecasting for fish farm management. Another application for coastal environment is START, that is an industrial, the results of a collaboration of industry and research center to provide the decision support system for storm surge, harbor forecasting and of wave and currents, and also information on coastal erosion in several, in the overall Apulia region, with focus on case studies in which also the forecasting is done in operational mode in several areas of the Apulia region. Here you see some of the examples. And the users in this case are more oriented to port authorities and local municipalities and the region itself for the protection of their territory and economic activities. Of course, we can foresee also exploitation more related to tourism sport activities along the coast. Here you see some recent development in terms of visualization. Yeah. And maybe, sorry, I had a problem with the presentation that crashes. I will recap very fast. So we'll not be able to see my visualization. Apologize for that, but I think a visualization, let's say, is not a part C condition, is not a specific product itself, but is key for the communication towards the users. And we are investing a lot in very high resolution unstructured grid model visualization so that very accurate information can be transferred to the users. Another important application we have developed for maritime safety is the search and rescue based on leeway model that is an open source and Copernicus data and the CNWF forecast. The user is able to predict or to estimate the optimal search area that is highlighted by the red area here with the yellow dots. So these dots are starting in the initial position where the person is lost at sea, and then the search area is identified using the characteristic of the object lost and the forecast of currents and wind. Of course, the most accurate are the ocean currents and winds. The most accurate will be the product. So the service in the end is a combination of technological development and state-of-the-art science-based forecasting capability. The same apply to oil spill forecasting. These products are also available in a simplified version in the Black Sea. In the Mediterranean, we have the wheat oil application online that is freely available for usage. Also, the Ocean SAR application is freely available, in which you can run simulation of an oil spill, estimating then the transport and the weathering of the oil. This is an example of a recent case studies with REMPEC, not case studies, it was a real accident in which REMPEC, through our collaboration, alerted and activated the Mongoose REMPEC emergency office. So in collaboration with the Greek office, with the Greek colleagues from HCMR, CMCC provided a forecast of the oil spill in the Piraeus area. One of the last application I wanted to show you about is about plastic in the Mediterranean Sea. We are trying to estimate the transport and the fluxes of plastic in the Mediterranean Sea. So first source are identified. Of course, this is a very an information that has with that large uncertainty. So one important activity that we have to do is to monitor where sources are, of course trying to decrease the input in the ocean, but also to better estimate the capability of modeling to better understand. Then we use currents and waves in this case to estimate the transport of marine litter, and the results is that where are the destination of marine litter, and in this case we can identify some of the potential hotspot. Of course, then, as I was telling before, we need the verification of this hotspot, but we see more and more that this information is, let's say, important for stakeholders that need also to plan the monitoring. And so from one side, it is important to understand the mechanism of transport of plastic, so where this could accumulate, why, and then how to monitor. And then, of course, also possibly together with the monitoring, it will allow to focus priority for cleaning and diminishing the impact on the coastal and marine environment. Last but not least, we need to communicate our knowledge and products to the users. Also, both the, I would say, the commercial and non-commercial one. And I would say that these fit in the context of ocean literacy. our contribution to ocean literacy has been exploited through mainly the support to sport activities, as sailing or free diving, and also through the production of a web service for the communication of ocean bulletin in some regions. So to finish, I think that we have go through the international framework that it's essential for the development of blue growth in Europe, in the world, and especially in the Mediterranean and Black Sea. CMEMS is the service that allow the exploitation and development both with the in situ and Earth observation and modeling, forecasting, and reanalysis products allow the exploitation and development of the blue growth. Without the collaboration of a research enterprise industry and users, we cannot really reach and develop a blue growth application that are keen then to protect the environment with, let's say, the capability of developing the economy at the same time. Thank you.
Thank you, Giovanni. Thank you very much for this very interesting presentation. In the meanwhile, I received several questions. I hope we will have time to address them all. I have a curiosity that might be interesting also to be discussed a little bit more with everybody. So you said that this blue growth initiative was mainly born to address user demands and to develop services to users. So we imagine that this is the last link of the chain, okay? But there is the first link of the chain that is mainly built on the models that we have, the numerical models that we have available, and also to observations. You mentioned the fact that satellite and in situ observations are fundamental, the fundamental bricks to develop the services, the blue growth services. So during your experience, can you comment on the fact, on the importance of having a free and open data policy for the observations? Can you comment on the importance of monitoring the ocean state and rescue data in the past to characterize the past of the ocean? But mainly, can you comment on the importance of sharing the data and having the data available for everybody?
Well, yeah, thank you for the question. That it's interesting. Somehow I try to answer during the presentation, but it's important to stress that observation and monitoring the ocean is one of the essential components of our capacity to develop service and therefore to develop economy in the coastal and marine area. I'd say that the GOOS framework and the effort of Europe to monitor the ocean is large, but is challenging because, for instance, it also includes somehow trying to coordinate the national effort, because most of the observations are collected at the national basis. There is a very important challenge that Europe has endorsed with EMODNet, that, as you know, is a sort of capacity of getting the data from the provider, let's say, and making them fully available to the user community, demonstrate the importance of the usefulness of the data in the value chain up to the application, and in collaboration with SeaMEMS also provide the open and free data access to the data. This is important. I think that also as a European community, we have started the discussion and of the development of the EOS, the European Ocean Observing System, that will somehow be the synthesis of our capacity today and draft the plan for the future observing system. We need also to not only to maintain what is existing, that is already a challenge, but also to develop a new capacity of observing. And I would say that the application itself in the future will become a sort of observing capacity of the ocean, also because the users will judge us from the observation. Our understanding, capacity of understanding the ocean will go through the application. So the free and open data policy is very important for the both, I'd say, the basic observation, the remote sensing in situ, and the ocean forecasting. I think that CMEMS is supporting. I think there is more need of support for especially for the in situ observation. So I think Europe should invest even more on together with member states, on its capacity of observing the ocean, so that this data then can be sustained, this observing system can be sustained, and also can be enlarged so that there are also new observing system can be developed and gaps filled. For instance, we have a huge gap in the African countries that we need to further exploit and develop.
Okay, Giovanni, now I will give the floor to the people who wrote their questions. There are several ones, and to start with is Noman Kadir, who has several questions. I'm trying to summarize as much as I can. Well, he's also curious about the other, fundamental component of the services, about the model, which are the models that are used or you personally use. And but not only the models, from the models to the applications, he has several questions regarding the possible services that the blue growth can provide. For example, he asked if seawater quality, heavy metals, pesticides, chemicals can be included in this framework, or if it's possible also to assess algal bloom production, if it's possible. And I think you already answered these questions, if it's possible to use this framework in case of ship accidents, oil spilling, or coastal flooding, and probably the most important one is if it's possible to transfer these software capabilities in other parts of the world, in other regions. So,
thank you, Noman, for the very challenging question. So first of all, models that I presented two applications. The Copernicus one is based on an EMO model. That is a consortium, European consortium that has developed an ocean model that is freely available, so NEMO model. The other application for the coastal modeling is based on SeaMEMS, that is still an open access model. We are building the consortium out of that for further sharing. And the difference is that, there are many differences. One is that it's a structured grid model, so allowed to zoom its grid into the coastal areas to very high resolution. Imagine that in the harbor of Taranto in Italy that I showed, we are reaching 20-meter resolution for currents. So that is a very high resolution, available only thanks to to the unstructured grid capabilities. Other possible service, yes, sure. I mean, I only presented the one that we have developed as CMCC, of course, in collaboration with other partners. There are water quality products. There is a very nice website on SeaMEMS, on Copernicus Marine Service website, in which all the use cases are presented. There are several for water quality. And so I presented to you the marine.copernicus.eu website. I mentioned it. Within that, there is a session on use case in which water quality, mainly based on remote sensing ocean color and temperature, but mainly, I mean, ocean color products are used for water quality. Of course, then also the in situ component can monitor the quality of the coastal ocean. I mean, not only the coastal, the quality of the ocean. And EMODnet is trying to open to new data. For instance, recently they have launched the component related to marine litter. That means that they are making available information on where the marine litter is observed, of course, still at basin scale. And also there is the EMODnet chemistry that is also include some of the component that you were mentioning. Harmful algal bloom, again, is services are developed as a combination of ocean color product and forecasting capability. So yes, they can be done. And our oil spill forecasting system has been used in the different phase of development, starting in 2006. Of course, it was at that time a desktop application for the accident in Lebanon, and since then it has been used many times, both for accidents from ships and for accidents from coastal disaster, let's say. Coastal flooding is one of the service that is typically developed. Is based on ocean forecasting modeling. I think there is also on the way a sort of revolution. Up to now, storm surge, coastal flooding was mainly developed through a simplified model that based on pressure and sea level forecast were forecasting the coastal flooding. Within JCOM, there is this discussion and framework on coastal storm surge service development, and I think CMEMS is more, Copernicus Marine Service is more and more going towards the capability of supporting the coastal flooding with its own models. The transferability of the service is key. Is important. So we have developed a capacity of relocatable our modeling of relocate our modeling capacity also at CMCC worldwide. We are already running CMCC is already running ocean forecasting in many areas of the global ocean. And of course, partnership are always very welcome to further exploit this in other areas. I would say that the fact that the CMEMS is covering the global ocean also support, let's say, international capacity of developing the service. Also, we are developing in CMEMS training. And this training is done also in non-European areas to further facilitate the uptake of Siemens products.
Thank you, Giovanni. In the meanwhile, I got a lot of questions. Maybe we can have some rooms for the last two. We didn't cover much the the industry and the market issues. So one question is, can CMEMS provide data for waves application to renewable energy?
Yes, sure.
And which are the big challenges to bridge the gap between the research and the market?
So the first question is very easy. And yes, CMEMS deliver waves forecast and hindcast and reanalysis for the past years. So these data are freely available on the web. Of course, might need downscaling as we do for the currents to have very high resolution. But for instance, in the Mediterranean and Black Sea, we released already 4 kilometer or 2 kilometer, 3 kilometer in the Black Sea resolution wave hindcast and forecast. And they are used also for renewable energy assessment. You have use cases on the SeaMEMS website. The bridge to the market, I think is first of all, the accessibility of data. So CMEMS is investing in building a new capacity to make the data more easily accessible, like the DIAS system that will be developed in the next months and years. So to make more easily accessible the data. The training is key. So again, Copernicus and we are also contributing to training intermediate users, so industry and stakeholders to uptake the data. If I look to the more let's say application service oriented of CMCC, I think one missing component is the marketing, is the capacity of being placed properly in the market, because also the connection with the users and the analysis of the user experience is very demanding for the new sector of the blue economy.
Thank you, Giovanni. And maybe we have time for the last, very last one, since it's a very hot topic, the plastic migration model. We had several questions regarding this, regarding the possibility to be applied to a global scale, and also regarding about the forecast capacity of this migration model at different
so
time and scales.
There are examples of the global ocean. I think that the uncertainty increased dramatically. So I'm not sure that we really can do assessment at the global ocean with the appropriate accuracy, but there are published papers on that. I think our capacity will be to do this exercise with more accurate currents information, so that let's say going more local than global. The forecasting, it has been foreseen for very specific forecasting of plastic. Has been foreseen for very not done, but foreseen, especially if you want to set up cleaning activities. We had planned to jointly, so people doing monitoring of the plastic, and then maybe forecasting could help. So short-term forecasting could help to optimize the cleaning of the plastic. There are examples in Europe and projects of developing new capacity of cleaning the ocean. Of course, for plastic, the key issue I think is to reduce, and Europe is investing in that, is reduce the amount of plastic that is input into the ocean. But of course, our, let's say, possible contribution is mainly, as you have seen, on modeling, understanding the fluxes, and eventually support for the cleaning.
Okay. Well, the very last one. What about the users' feedback? How are the users' feedback
collected, you mean?
Collected, yeah, and inserted in the chain that you presented?
Yeah, I would say there are two components that, at least at my knowledge, that of course is partial, that has really focus on user. One has been EMODNet with the checkpoint that has deeply analyzed how the observation and products were fitting for purpose, so how the user demand was answered. And I think on the EMODNet checkpoint, especially, I mean, for sure on the Mediterranean one, you can find information on how at least the products are appreciated or not by the users. The other effort is done by Copernicus, Copernicus Marine Service, and also through the Copernicus Uptake project. We meet the users regularly through training session, and last year we have been organizing Copernicus. I mean, Copernicus has organized the Marine Week in Brussels. In that room, in that week, we met users, all of us. I mean, the Copernicus family met the users, and of course interact to understand. So we have in Copernicus a plan for the next 3 years that has been developed, taking into account the feedback that Copernicus and Copernicus Service Desk has acquired. Of course, there is much less organized, because it's also larger interaction, is more difficult to the interaction of application users, so the users of the different application. There is an effort, but they are very difficult to meet, and we need that the market itself grow, so that the industry and the company will be more and more able to listen and to uptake the users' demands.
Okay, thank you again, Giovanni. I think this was really the last one. Thank
you. Of course, you can sorry, I mean, people can email and
Exactly. I was saying this. If we haven't been able to answer all the questions, and we have not, I know people can send an email to Giovanni. And I remind everybody again that the seminar, the presentation will be available on YouTube and on the CMCC website. Several persons asked me about the slides. Yeah, and just to conclude, thanks to everybody. Thanks to all the participants that are still online. So it seems they have been interested in your presentation. But I want to conclude with the date, and if you can go to the next slide, we should have exactly the next forthcoming webinar, CMCC webinar, will be the 5th of April, so very soon. And this time we will have Gaël Giraud, who is the Executive Director of the Innovation, Research and Knowledge Agency for French Development. With the moderator will be Professor Carlo Carraro from Ca' Foscari University. You can see the title of the seminar will be on carbon pricing and global warming, stock flow, consistent macro dynamic approach. So please come back for the next seminar, and thanks to everybody again. Thank you.
Thanks to everybody. Thank you, Simona. Thank you so much.
Bye-bye.